This demonstration is for FM sound broadcasting. That is one important part of the capabilities of RAP when it comes to handling of broadcasting applications. In a first video in this series, we demonstrated the use of RAP for digital TV. And that video also contains some introductory general capabilities that also apply to the broadcasting, FM sound broadcasting. So all videos in the broadcast library should be viewed to give a fairly good overview of what RAP can do. I have started RAP by clicking on the icon on my desktop. I log in as guest, which requires no password, and that's okay for me in this demonstration. And this project opens with an empty window, basically just showing connected databases. I start another project to give me a map of interest over the area of interest where I'm going to create radio stations. And the purpose now for me is to create a new FM broadcast station at a village. Here it will be a small low power station with the intent of giving coverage for 10 kilometers or so in the rural areas. So I use a prepared template for this low power station, and I call this with a name here. I'll call it, let's put an A at the end, because I may have already created this in the database, and this is just to make sure that I have a clear identification of it for this particular demonstration. It has a frequency 87.6 megahertz, which I can change by double clicking and editing, or I can select from a channel plan, from allotment, but I will stay with this frequency. It's not important now because later in the presentation we will do an automatic assignment to give it a good frequency. Some detailed technical characteristics of this station are here. It's a 35 dB watt radiated power, around 3 kilowatt or so. A low antenna for a broadcast transmitter, only 30 meters, because the intent was just to cover a small area. The broadcast specific tab allows calculation of the effective antenna height, and I'll do that by pressing the calculate button. It then calculates for each 10 degree increment the effective antenna height, and this is used in a further coordination process that is the subject of another video. It is for coordination and notification according to procedures prescribed by the ITU. This transmitter has a stereo broadcast sound, stereo, it says, a modulation FM. Yep, that's correct. I do not enter any time delay. This may become of interest, may be important if this is to be part of a network of synchronized FM stations, where we may need to adjust the time delay a little to reduce interference in the single frequency network. But now we will not use this for the example. So pressing OK creates the station at this location, and it appears in the list here. Further now of interest is, of course, what other stations exist in this geographical region. So to find out, I will draw an area in the map which will be my search area when I search a database. Let's just, for the demonstration, assume that a 40-kilometer coordination distance is sufficient. That may be or may not be sufficient, but for this particular example I know that it is sufficient. It's a low power station. It will not have very long range interference, extreme long range interference. We will use now the FM TV database by the as defined by the ITU, as registered by the ITU, I should say. Use the search engine here, and we'll select class of station. I'm only interested in broadcasting station sound, BC. The database itself contains television also. And I'm only interested in, I'd limit the search further to the Geneva 84 fragment of the database. The Geneva 84 sound broadcasting plan. Pressing OK invokes the search. It gave me a total of 30 stations, as I can see in the status bar in the project window. I add these to the project, add to project without results, because that's the procedure we use for the calculation. We don't calculate directly on stations as they are stored in the database. We add them to this project file, which can be saved with its station contents as a single file. And now we have the new station and the 30 existing ones. Let's have a look at the spectrum content in terms of field strength. Now when I place the cursor somewhere in the map, and if I press the left mouse button and move the cursor, the spectrum view is updated. It shows field strength on the y-axis and frequency on the x-axis. So now I'm on top of the new station, and at that location it gives, of course, a very high field strength, 120 dB microvolt per meter. And when I move around here, it updates dynamically. So this gives an indication of where there seems to be frequency space available. But this will naturally have to be calculated with consideration to protection ratios, co-channel, adjacent channel, image frequency, and so on, protection ratios. And that is exactly what we're going to do next. So the new station, I mark the new station to start the broadcast tool of RAP. And the procedure here is first to select an allotment, and that would be the allotment or channel plan, the broadcast FM channel plan, which is all 100 kilohertz spaced frequencies between 87.6 and 107.9 megahertz. If we already know or have a national plan or a regional plan to use, that can be created with and removing, and from that plan could be implemented in a way that some of the frequencies are not available for new stations because they are protected, so there's no possibility to reuse them, and they can be taken away. But that anyway is automatic in the broadcast tool, because the frequency assignment calculations will calculate all the interference contributions on each frequency of the channel plan. So for the propagation model selection here, I'll select the popular P1546 as defined by the ITU for the wanted signal, and I'll choose the same for the interfering signal. I could select other propagation models also, but since it's quite common practice to use this recommendation, we'll do it. I want to do this analysis and assignment for a lower normal antenna height, perhaps well, it's 2 meter typical for a car radio antenna. 10 meter is perhaps more typical for a fixed reception, and the nominal height where much broadcast planning takes place. But all the corrections for the lower antenna height are taken are performed automatically. This environment, reception environment, to define here is rural, because I want reception to be possible in the rural areas around the village, and the reception is not really intended to go into the city of Linköping here. So we'll do the rural environment. And probability of interference, I'll set that to 1%, which is a very conservative interference requirement. We have several interference summation methods that can be selected at will, or at the selected method of preference at the particular administration using RAP. Pressing OK starts the calculation. During the calculation, it places test points automatically. I will come back to test point placement when we do the interference analysis part of this. Marking the station now shows the interference that it will give to existing stations and what it will get from the other stations as a function of which frequency to choose for it. Right now it is using 87.6 megahertz. If I mark 87.6, we can see that the margin is a positive value, which means that the worst interfering station to the new station gives an interference that still allows almost 13 dB of a margin. So this means that the interference is 13 dB lower than the maximum allowed interference. And for the reverse, the worst interfered station, that is the new station interfering to the others on that particular frequency, it gives similarly a margin of 8 dB. So this is actually a good frequency. The diagram shows in colors the frequency in use by the marked station is shown in blue, 87.6. Red frequencies indicate that if I were to assign these frequencies, there would be interference, so I really should not assign the red frequencies. Yellow frequencies are okay to assign. If I assign them, it will give sufficiently low interference. And assignment can be done manually with the assistance of this diagram. So if I, for instance, select 89.9 megahertz, I can double click there, delete the existing frequency, which is the common way of doing. Now I have assigned 89.9 megahertz, and the details of that assignment in terms of interference are like this. 14.5 dB margin towards the worst interfering station, and worst interfered is 1 dB. Now this can be done automatically also, of course, if we use the assign feature here. So I'll demonstrate that. Assign. Then it first asked me whether to remove the frequency on already assigned stations. Yes, we want to do that because the new station is only supposed to have one frequency. Yes. Then it gives me a selection of algorithms for sorting order and selection order and so on. All the details of this is described in the detailed documentation of RAP, so I won't mention anything more about it. Pressing OK performs the assignment, and it selected 87.6, which was actually its original frequency. So let's stay with that. Then the next tab, interference, that allows detailed analysis of the result at each test point. So first I calculate to update to make sure that the interference calculation really reflects the newly assigned frequency. And marking the station lists all the test points that were calculated, at which interference was calculated for this station. This is as interfered, so it's the other stations interfering with the new station. And I can sort on margin here to find the lowest margin, and this of course should be positive all the time. If I have a negative margin here, it indicates interference. And showing as interferer, which is also okay then, positive, all positive margins, that's good. This shows now as interfered the test points where the new station gives contribution to the interference to these stations. If I click here, show all test points, it will be all the test points distributed, and it will also show test points where actually the new station does not have a contribution, like this one. If we sort on the nuisance field here in dB microrod per meter, we can see that there is in particular one station that gives a very high nuisance field, 95 dB microrod per meter. There is a reason for that, and it is that there are actually two entries for the same station, or almost the same station, in the ITU BRIFIC. They have different numbers here, but you can see they have the same frequency, same station name, and if we have a look at the geographical coordinates of these two entries, they are very, very near each other. And actually, it's only one of them that is in real operation. The test point locations can be shown as interfered test points, show in map, location only. So this is as interfered, and these test points are distributed then obviously around the new station because they are placed at the wanted field strength, where the wanted field strength of 54 dB microrod per meter, which corresponds to the rural environment, will be achieved by this station, and at that limit of the coverage area the interfering contributions from all the other stations are calculated. As interferer test points are shown here, and these are shown at these test points are selected at the limit of the coverage areas of the existing stations, and the new the interference contributions from all the other stations are calculated at those test points. And in particular then it's of interest to see what the new station gives in terms of interference. So we have now performed interference checks. We have optimized the frequency assignment to really make sure that this new station does not give interference to the existing ones, and the other way around. It is not interfered with by the existing stations. So I'll save that new frequency. Like that, and now we know that this will work in terms of interference in this area. I'll save this in the database now, save the new station in the database, and the purpose of that is for a continued video presentation on coordination, because the coordination started by the coordman function here generates the proper coordination and notification messages according to the ITU procedures, but that's the topic of a separate presentation. So this concludes this demo of FM broadcasting